And we are really happy to have today our first keynote, Vincent Traag, well known in the field. We have been using or reading about the Traag algorithm for community detection. Is a senior researcher at CWTS, and very involved in this project that we will hear more about in the presentation, and also the engagement and inclusion focal area at Leiden University. So welcome, and thank you.
Thank you. Thank you also for the invitation. And hi everybody. I'm very happy to be here and talk to you a little bit about one of the projects that I'm involved in. Actually, it's called PathOS. Some of you actually might have attended STI. There will be some similarity with parts of that publication, with presentation, but I promise you that there will be new elements. So PathOS was sort of a joke when I previously presented something on PathOS that people were thinking was pathological or these types of things. No, it's emotion, PathOS, which comes into play also in open science, and that's actually what the project is about. It's about impact pathways of open science and studying those. And in particular, it's about causal questions, let's say, and problems and issues that emerge in the study of open science. So the project as a whole is together with a whole number of partners, and the central goal is to better understand and measure the open science impacts and their causal mechanisms. And so this means that we're studying the entire pathway, or have an interest in the entire pathway, going all the way from the very start at the resources until the impacts and everything in between. So going to actual activities and outputs, open science outputs, outcomes of those outputs, and then finally impacts. And impacts also in a very broad sense, covering academic impacts, societal impacts, economic impact, and also with an interest in issues around reproducibility. And some of the examples are shown here down below. So looking at financial resources or legal frameworks in terms of resourcing that might end up funding particular activities such as repositories, either for data, for preprints, or institutional repositories of actual publications that are then able to, for instance, host particular outputs like open data or preprints or the actual publications, which end up having particular outcomes. And so this again varies from data reuse to reproducibility, productivity, reliability, efficiency. The ultimate goal, let's say, or the ultimate interest would be in this long-term impact. Open science might help stimulate innovation and ultimate scientific progress at large, perhaps can help establish or improve trust in science in one way or another. So these are very complicated aspects, obviously. And so this is just one project. And so obviously we cannot study the entirety of this, right? So we cannot say, okay, we're beginning to see with all of these resources, all of these activities that are taking place, and all of the different impacts that and outcomes and outputs that can take place. And so instead, what we aim to do is essentially three types of things. So the first is to do a review of the literature, of the current existing literature, with a particular attention on questions of causality. And simply see what is out there in terms of overall evidence of the impact of open science, all types of open science and all types of impact. So it's quite a broad review that we actually already did. And secondly, do a couple of case studies that investigate a few specific elements of let's say, the overall impact pathways. So not try to study everything. Finally, also making available some indicator handbook providing an overview of what elements of open science we can currently measure, how well we can measure them, trying to provide concrete pointers to this is how we could measure them, or simply also try to be honest about it. This is what we would like to measure, but we're not really able to do that. I'll get to that later in the presentation. And again, all of this with a name on, with a focus on causality. So let's start with the scoping review that we did of open science impact. So in total, we screened about, I think, somewhere between 4 and 5,000 publications, of which ultimately some 300 or so publications ended up in the scoping review of open science impact. And here the inclusion criteria were really specifically about the study addressed a particular impact of open science, right? So it's not just general guidelines of open science principles or suggestions for how to do something in terms of open science practices, but really studies on the impact of open science. And as you can see here, most of the studies actually have to do with open access. That's by far the largest type of open science activity that has been studied in the literature. In colors you see what types of impact is being studied in this, let's say, part of open science. And here you can see that in open access, by far most studies have studied academic impact specifically. Some have studied societal impact and very few economic impact. Then there's a large portion of citizen science literature. And that is a bit more aimed also at societal impact, which makes sense, right? Citizen science is about including citizens in one way or another in the research process, either up front when trying to come up with research questions, or later down the line, data collection, all these types of issues. So it makes sense that this is a better studied aspect of citizen science. It's a little bit less focused on academic impact, as most of it societal, and none of it economic impact. The rest of the parts of open science that we discern here, so open data, open science general, open evaluation, so this includes open peer review, open code and open methods, have had far less attention. The attention that has been there has been mostly focusing on academic impact. And again, very few publications on economic impact, and that's about it. So these aspects are relatively understudied compared to open access type of open science. The economic impact, as you see, is almost negligible. So the literature that we found during our scoping review, there's almost no evidence of economic impact of open science. This, of course, doesn't mean that it doesn't exist, right? There might be impacts of open science in economic sector, but it's simply understudied, and so there would be more attention needed there. So in terms of academic impact, so that's on the right here, what is actually studied. So the first is essentially the same type of information as on the left figure, so I will explain it. But what are the types of things that are being studied within academic impact? So sort of subtopics. And here again you can see that there are essentially two types of things that are the main focus is citations. And most of it is this so-called open access or open data, or other types of openness, citation advantage. And this is by far the most studied part. There's already a couple of reviews actually on that particular topic already done. And if there's anything of this whole scoping review, it's that there's evidence on, there's a lot of literature on this particular topic. Some of it is a bit mixed still. Second aspect is quality, and this also has a lot to do with quality of research and concerns of quality, mostly related actually to more predatory publishing practices. And this is what has been studied in the literature as well. Again, with some varying findings, trying to compare quality of research from open access to non-open access research in one way or another. And then there's a whole list of other types of factors that are studied, but that are much less represented here. So when we look at what is actually then found within these all of these publications, it's essentially this type of overview. Some of the font is a little bit smaller than I originally had hoped to, but so for academic impact, all the way on the left, as said, it's by far the best researched. And so we have the citation advantage in open access that has been researched a lot. Then there's the sort of equity type of concern with APC publishing, where there's a concern about non-equal access to publishing. Right, so the APC, the author processing charges for publishing, raises another type of barrier. Previously it was possible or difficult to read it if you didn't have funds to be able to subscribe to particular journals. And now it's reversed in a sense that it's possible to read it, but it's not necessarily possible to write it. For open data, much of it is actually also focused on reuse. So there's been a lot of studies on introducing one particular data repository or sort of a platform, a sharing platform, in a sense perhaps similar to what we just discussed in terms of platforms and data. Much of it is simply focused on seeing there's been a new repository and we see it's being used. That's essentially covered already quite some of these studies. Another aspect is the citation advantage, and that might have to do with the reuse, in the sense that a publication that is introducing a particular open data set might end up having more citations because it's not only cited when it's being used, the publication, but also when the data is being used, and they cite the original publication. And so there's also this citation advantage of, if you make data available, that the publication itself might end up having more citations. Then for open code and software, again, there's a citation advantage issues being studied there, and issues around efficiency. So if you're able to reuse the same code again, it makes part of the research more efficient in that sense. For citizen science, as I already said, it's about data. Collection to some extent, and that's actually the largest part of the literature there, and particular also issues around data quality. So as you can imagine, if there's citizens involved in data collection, they might collect data differently from experts in the field. So you can think of experts might be better able to discern different bird types or something if you're asking for bird counting citizen science projects. Citizens, if you ask them for, I don't know, walking around and counting different varieties in trees, then you see that observations are mostly being made along a walking path, while you would like to have a more systematic type of inventorization of what is happening in the forest. Now, I'm not a biologist, I'm not an expert in these things, but these are the types of concerns that are being studied, and where there are sometimes these types of differences between expert data collection and citizen science data collection. Finally, open peer review. It's not very much studied. It's also perhaps a more recent development. What is in the literature until now doesn't suggest that there's at least not a negative outcome in terms of quality of research or these types of aspects. It's either neutral or positive. So it's overall it's a sort of a positive note, but there's not a whole lot of evidence on those aspects. As said, for societal impact and economic impact, there's much less evidence overall. So for open access, it's mostly about making it open to public also, so that there's more public interaction in general with open access publication. Citizen science I already just explained. Economic impact is, well, I can just capture it with one phrase: limited evidence. What we have until now is just a scoping of the literature based on keyword search, and so this is what's in here. So the publication, the review is available from Zenodo. What we're working on currently is trying to do a sort of a snowball approach to get more literature in. We then do seem to be able to find a little bit more literature on economic impact, but it's not overwhelming, it seems. And there is obviously also some other literature on some of these other areas coming in. Remains to be seen what is in that literature from snowballing it. We're also including more grey literature, so more policy types of reports that might contain some relevant evidence. So it will be updated in probably a couple of months. The picture overall I don't really expect to change. in the sense that there's, for some areas, just really limited evidence. Okay, so this is what is in the literature so far. And as I said, what we want to do is also try to study how things do some new studies actually, and trying to contribute to part of the literature. We've had a couple of different, two different setups, let's say, one more theme-based focused and one more country-based focused, where the theme-based focus is more on the different topics that we will research. So it's one on bioinformatics, where there's a large platform or collaborative structure, Elixir, involved that produce bioinformatic resources of various types, and there we will look at industry uptake and usage of those resources, and how they actually can build other services or other types of products based on the resources that are made available by Elixir. In the COVID-19 study, of course, during COVID-19 there have been a couple of developments in science, so pre-printing, but also the rapid sharing of research data, and we'll be looking at these factors and trying to study the effects that it had on in essence how the development went during COVID-19. With climate research, we'll be looking at Horizon 2020 open access mandates and trying to study how that changed climate research in particular. For gender, there's a similar type of question with gender plans that are now required in Horizon 2020 proposals, but some countries already had such gender plans in place before, and so there's an attempt of trying to disentangle how these gender plans will actually affect certain outcomes in terms of publishing. But there are also concerns of open access publishing, for instance, that there are different barriers and there's different funding rates across different genders, which might play into inequities in this area. Finally, in terms of the three case studies below, we try to take a couple of different countries and see what they, how they feed into this open science studies. So in the Netherlands, we will be looking at a particular data repository and trying to understand how the data repository itself affects the reuse of data. So does it make a difference where you share, let's say, your data? Can you better share it on a disciplinary, global type of data repository, or is it better in a national repository? Does it make a difference? Perhaps it doesn't make a difference at all where it's shared, as long as it is shared somewhere. So this is what we'll be looking at in the Netherlands. In France, they will be looking at a couple of the open scholarly platforms in France, HAL, Open Edition, these types of things, and how they're being used again by industry, but by tracking sort of online usage of these platforms. So that's a sort of innovative type of approach in order to try to track based on access logs and these types of things of where actually the open material is actually being used. And finally, in Portugal, there's a national network, let's say, of repositories that is linked together, that is indexed by a single indexer for Portugal more broadly, and the impact of that is in focus. So this will be the case studies. These are in active development, and some of them have already started working out some of these elements, but we expect to kick them off more in the following 2 years. And finally, there's then the next element that we'll be making available, and that's the indicator handbook, the Open Science Indicator Handbook. So this is something that we decided not to make available as a traditional PDF. So the scoping review is available as a traditional PDF, let's say, on Zenodo, but this is available as a website. It's also available as a PDF, but the PDF is, in my view, much less usable than the website. And so the website is actually what is hopefully most useful to the community. So it should be easily navigable, looking at different aspects of open science and the impacts, so being able to easily find a particular indicator of interest, and that might be of interest either for monitoring or for doing a particular study on a particular topic, and then find, if possible, particular pointers to this is how you can measure it, these are the data sources that you can go to, and this is how you can implement that particular indicator. At the moment, we've only covered open science and reproducibility. We haven't covered yet the academic, societal, and economic impacts. This will be developed further over the next couple of months. It's also open for, let's say, your contributions. So it's just hosted online. It's the repository itself is on GitHub somewhere. If you see something that you think, okay, well, this is nonsense, I know much more about this topic, and this should actually be not done like that, it should be done like that, feel free to just come to the repository, say, okay, you're wrong, or maybe just say, okay, there might be a better way to do it. That's also possible. But anything that you would like to contribute there is more than welcome. So these are the three aspects of the project, and then I like to continue with something a bit more about the causality aspects, because it's in the end these causality aspects that are relevant. And this is also something that comes into play here with the indicator handbook. And what I want to differentiate there is that the impact of open science is not the same as the effect of openness on impact. And this is something that is a continuous discussion also within the project, but also across many other partners, that somehow this impact notion contains in it both the effect itself and sometimes not. So it's a bit, let's say, ambiguous. Sometimes if we talk about academic impact, and we're talking specifically about scientific impact, or even more particular citation impact, it's okay, it has impact if it is cited, or if it's reused, for instance, and we can try to track reuse or these types of things. And there is a difference with the effect of openness on that impact than just the impact. So open science can have an impact, but the impact is not necessarily realized because it's open, right? And these are two different things. And so, for instance, if we make a particular piece of software available, it might be it might have a particular impact. It might be very much reused, either by industry or by academia itself. And so that's all great, but it might be that it also had a similar use and a similar type of impact, in a sense, if it were not made available openly. Right? And so there it's the question, well, great, it has impact. Is that really due to the openness? Did the openness change anything about the impact? Or do we just show the impact itself? And this is also something that then is relevant for the indicator handbook itself. So for the indicator handbook, we have, we had this open science section, and so that covers all these different types of aspects, open access publishing, open data, open code, open review, open methods, and many, many, many more. And then we want to know, well, what is the effect? And so the effect on the impact in terms of citation impact, in terms of collaboration, reproducibility, engagement, etc., etc., etc. And this becomes hugely problematic, right? So if we want to develop an indicator, we can't say, okay, this is how you measure the citation impact or the impact on public engagement of open science, because first of all, open science is not one thing. Open science is a gazillion different types of things. So we would have to develop for instance, the public engagement already 10, 20, 30 different indicators for each aspect of open science that we would be interested in. And then it's not only the aspects of open science, it's also, is it about a mandate? Is it about a policy framework? Is it about a particular investment? And then there's different types of levels of, okay, it's about open access publishing, okay, so it's not necessarily about making the repository available, it's about the publishing itself. So again, different questions. So if we have to do this for all the types of open science that we're interested in, all the different aspects of open science that we're interested in, and we have to do this for all the different types of impact that we're interested in, this just becomes a combinatorial number of indicators that we would have to provide for whatever aspect and effect of open science on impact you happen to be interested in. Now, this is simply not possible. At very least because of lack of time. If we want to do this, this is just way too much work. The second aspect is that each of these requires a lot of thinking. It's not just that we write down, oh, well, you compare, let's say, open access with non-open access publications and then you're done, right? We'll see how that actually might end up being problematic. And so if we want to provide an indicator for a specific effect of open science on impact, we really have to think through how can we identify this particular effect. And that requires thinking through for that particular question. And doing that requires quite some time and effort. And so that's why we decided, okay, we won't be attempting to do that, because as soon as we start to provide it, then people will think, okay, well, oh, this is how we measure the impact of openness on whatever aspect we happen to provide. Right? And then it starts to become problematic. I'll explain why. And that's essentially this idea of that the indicators themselves, as soon as we start to provide these more fine-grained indicators, interpreting them and drawing conclusions from them is much more difficult than just looking at these indicators, whatever indicators you happen to provide. And so interpreting the indicators themselves requires causal thinking. And I prepared a small simulation for showcasing what is exactly the problem with these types of indicators, or what are potential problems with these types of indicators. And so it's just a simulation. There's no real data, right? There's nothing that I measured in reality. And in this case, it's about the effect of open data on reproducibility. Now, open data we might be able to measure in reality. Reproducibility is, of course, much more difficult to measure in one way or another. Right? Here it's simple because I just simulated it, so haha, easy way out. But we might think that we actually did a number of reproducible replication studies of particular research questions, particular publications, and suppose that we, for instance, ran some experimental study looking at how open data actually changed this outcome in terms of reproducibility. And so this is what's in the plot here, right? So suppose we did this experimental study, and here we see that open data reproducible. So let's say 75% reproducible, in the sense that on average we expect 75% of them to be reproducible or thereabouts. And here, if there's no open data, we can see that it's lower, somewhere around 58% or so. And so here it's clear that there's some effect. Right? So there's a clear effect of open data on reproducibility. Since I simulated it, I know that there is a clear effect, right? So there's nothing that we need to wonder about. Is there an effect? Yes or no? But now comes the problem. Now suppose that we have we have this type of knowledge from one experimental study or another, and then we start to observe things for real. Right? So I said we have just an indicator on reproducibility. We don't prepare or try to prepare indicators for what is the effect of, in this case, open data on reproducibility, because that's a different question. But suppose that we have some sort of open data mandate in internal peer review, and then we measure the reproducibility of publications. Right? So we measure it, and so here we find it's 50, whatever, 55 or so. And so, okay, well, nice, 55%. What does that mean? Right, it's difficult to put in perspective. So 55%, well, might be a little bit lower than you would like to have, or might be higher than you perhaps expect, given some reproducible statements in the literature. And so what you might end up doing is comparing it, right? Since you might compare it to, for instance, before, and say, well, if there wasn't a mandate, the reproducibility was actually 60 whatever, 62 or so, and now actually you introduced this mandate and now it went down. It's below 60. It's 55 or so. So that's not good, right? Something is going wrong here. And you might think, yeah, okay, but you're throwing everything on a pile. You shouldn't do that. You should prepare proper indicators for the open data publications and the non-open data publications, because perhaps something else changed, right? And so that's why you should have actually these particular indicators of the effect of open data on reproducibility. Okay, so let's try to split it up, right? So we have an indicator of reproducibility for the open data and for the non-open data in the case of this mandate, right? And so what happens then? These are the indicators. Okay, so now I'm a bit puzzled. The open data is now the reproducibility of the non-open data, so publications without, is 0.9, almost 90%. And with open data, it's about 50% or so. This doesn't make any sense or whatsoever, right? And so you might think, okay, this really isn't working. Open data doesn't deliver at all what we thought it would deliver, right? Just a couple of slides ago, we saw this clear effect, and we really believed that there was a causal evidence of really there is the effect of open data, and here it says no, that doesn't make any sense. If we actually do this and draw this conclusion, we would be wrong. We would be wrong in drawing the conclusion that open data wouldn't work based on this particular example, right? And this illustrates why we shouldn't develop, let's say, simplistic indicators of saying, okay, this is open data, this is the reproducibility for only publications with open data, and here it's the reproducibility of publications without open data, and then you can use them in practice. Well, you can use them perhaps, but you have to think, again, very carefully about what is happening. And what is happening here is the following. So, in this, and again, it's a simulation. In this simulation, what I've done is that there's two elements that are affecting reproducibility. It's open data, right? So things that are more reproducible are affected by open data, and it's affected by rigor, right? So there's two elements relevant there. And we said there's this open data mandate, right? So we're starting to actually make the publication decision also conditional on whether stuff is being openly available or not. Right? Sometimes there might be a reason for not making the data openly available. There might be privacy issues. There might be licensing issues. So it's not always possible, but if it's possible, it should be the case, right? And but the publication decision is also being affected by something else, namely the rigor. Right? So reviewers typically look at the study and say, well, the methods are appropriate for its question. The method seems to be properly applied. The data is well collected. Whatever. All of these aspects around the actual study, right? That also have to do with rigor. I'm not saying this is complete, right? There's probably tons of other things that might come into play here. So there might be, considerations of novelty, particularly in some journals. There might be considerations or actually biases of all types of things that we don't want to in there in a publication decision, like reputational effects of affiliations, of authors, etc., etc., etc. Right? But I just took this just to keep it somewhat manageable and somewhat simple. Okay, so this is the type of model that I simulated, and well, actually, some people that followed the summer school might be able to see what's going on here already. So what we did is looking only at the reproducibility indicator for published work. Well, what is published? Well, it's published if it has open data or is rigorous, right? Preferably both. But if it doesn't have open data, it really needs to do a good job, right? And so what is happening here is the following. So this is the plot of here. There's a measure of rigor. It's some positive number that I came up with magically. I have no idea how to measure this in practice again. Simulate it. So some measure of rigor here on the x-axis, and the reproducibility again on the y-axis. The crosses denote open data, and the circles denote no open data. And what is happening here is that, well, the stuff that is has open data tends to be less rigorous, and because it's less rigorous, it tends to be less reproducible. And why does it tend to be less rigorous? Well, this is not the complete picture. This is just a partial picture. This is a picture of only those studies that are published. In reality, there's a whole host of studies that are not published. And so these are behind here. And so all of the studies that are behind here, so the circles, they're not being selected for publication. Why not? Well, there was another publication, it had open data. Right? We're starting to mandate open data. So there was a particular study, yeah, it was rigorous, was good. It didn't make it data available. So no, you don't get published. Right? And that generates exactly this type of effect. Right? So you either have to have open data, or you have to be rigorous, but if you're neither, you're out. Meaning that if you're not providing open data, you have to be rigorous. Or in other words, if you provide open data, you can get away with being a little bit less rigorous in order to be published. Right? And so this is essentially what explains his observation. Because the rigor has, well, in this case also a larger effect on making stuff reproducible than the open data. Open data helps, sure. So if we would take one particular study and say, you have to use open data, that particular study should become better. But what we're doing here, instead, is just selecting different things. And that's something else. So, if we go back to this notion of this indicator of reproducibility for open data publications and non-open data publications, we would be drawing the wrong conclusion. This is what's behind. And so if we want to make sure that we draw the right conclusions, we need to have this causal thinking behind it and actually try to think of, okay, well, what might be happening here, instead of going and jumping quickly to the conclusion, oh no, open data isn't promising on its isn't delivering on its promise. There actually have been some studies, not in terms of reproducibility, but for instance in terms of consistency of reported numbers, like comparing t-values and p-values and all these types of things. You can calculate them from the one from the other, and so if they're inconsistent, it might indicate some sloppiness and, well, might have some relationship with reproducibility. In these types of studies, some also show this type of effect, or at least see that after introduction of an open data mandate that it doesn't improve the situation. I'm not saying this is the explanation, but this might be an explanation, right? And so the problem is, of course, this is a simulation. Here I understand what is happening. Here I understand exactly what is the case, and I can explain it. In reality, I can just observe and only observe the reproducibility for the open data publications and the reproducibility for the non-open data publications. And so we have to go from these observations to actual conclusions. And in order to do that, we need to make assumptions. So in order to have these causal conclusions about you should use it, you should use this open data, or you should stimulate this open data, we need to have these causal conclusions. In order to do that, we need to make causal assumptions. And these causal assumptions mean that we have to think of, well, how could the world work in terms of what is affecting what? And if we know, or have some idea, or have some hypothesis of this is how the world might work, we can then suggest, okay, well, if this is how the world works, then if we control, we can control for the publication. Oh, then this might actually be an explanation for why this reproducibility went down if we introduced this open data mandate, right? Not saying it's correct, but that might be one possibility. And so the essential question there is what to control for, what to take into account, what to do when we make all these types of observations. And usually, or let's say that's what I've actually been taught myself at some point during social sciences is, well, what do you control for in your multiple regression analysis? Well, you just try, right? You throw it all in, and then, well, if it's robust and it doesn't make any changes, it's all good, and why not? And this is something that I like to argue against. So we have to think properly about what to control for and what not to control for. So this idea of this publication, if you control for the publication decision previously, or just look at the published version, you're doing the wrong control. It gives you the wrong answer. So it's not necessarily that if you just start controlling for everything that you give the right answer. And so sometimes, and that is of course the ideal situation, you might say, well, we can run an experiment. We just randomly select a couple of research groups and say, you use open data, you don't use open data, and then we see what happens, right? And so sometimes that might work, right? And with open data, we might be able to get away with such a type of analysis. But of course, making an open data repository available, well, we can it's difficult to say, okay, we make one available, but only for this group or something, right? That would be rather difficult, or we randomly introduce it somewhere. Sometimes this is simply not possible. And if that's not possible, we have to think about what do we do then? What do we control for? And this is actually more difficult than you might imagine. So this is just a very simple example, right? So here I included this effect of rigor on open data. In reality, it might be there, right? In the simulation that I just showed you, it wasn't there. Even if I include it, the whole example works as well. But so suppose that we include it. Now, typically what you would say is, well, here is open data and reproducibility. We need to control for the confounding factors. Right? Well, there's one confounding factor here, it's rigor. Right? So we control for rigor, and then everything is good. And again, that doesn't work. Not here. And so we need to think about, well, what do we need to control for then? And the right answer in this case is we need control for rigor and formal theory. We could also control for rigor and resources, or we can control for all of these three. But we need control for at least one more beyond this rigor in this case. Otherwise, problems emerge, similar to the problems that I showed. I won't explain why exactly. But if you want to understand why, start looking into this type of literature on causal inference. Now the problem often is that we can't identify or we can't study some of these aspects. Like here it's rigor is also influenced by whether there's a formal theory in the field. Well, maybe we would be able to observe that and we would be able to come up with a measure of that. Here it's a measure of resources. Yeah, that might be much more difficult to measure. Many bibliometric studies won't have it available, right? So reproducibility is of course also very hard to measure. And so sometimes, if we can't measure these things, then it's simply impossible to say anything about the causality. And that's not necessarily a problem. Of course, it's a pity. It would be nice if we were able to say something about it. But we're simply not always able to do that. And if we're not able to do it, we should be honest about saying, okay, this is the type of findings that we had. These are the observations that we made. We can't draw this causal conclusion, right? But if possible, we can at least say, well, we can't draw a causal conclusion because of this and this and this and this. That provides additional, let's say, argumentation and clarity on what we're actually doing. So, well, let me skip that. So, wrapping, let's say, all of this together, what do we need? Well, first of all, we need more studies on the impact of open science. Most of it is focused on open access, and then most of that is focused on citation advantage. We've seen that, let's say. There's plenty of studies on that. We need to have studies on different directions of open science and different impacts. And in particular, we need to be careful about the causality there. And so I've in the abstract I also promised, let's say, ways forward. This is my 3-step procedure, let's say. So at least be clear about whatever it is that we're trying to measure and trying to say. What I say here below, this I think is at least as important. If something is not possible, be honest about it. It's not a problem if we don't know. We don't know a whole lot of things. Right? There's plenty of things that we don't know and can't provide an answer. And so we shouldn't pretend that we suddenly did. We should be honest and say, okay, well, we don't know exactly for sure how this works. And so the final conclusion, and so this is, well, sort of partly repeating what I just said. The last point I do want to emphasize. So what I'm not arguing for is saying, well, there's no causal evidence, and so we shouldn't do anything until we've sorted it all out, right? Because typically, well, what's the last sentence that we say in almost every publication? Further research is required, right? And this will continue to be the case. And so there's always going to be discussions about causality, and there's always going to be discussion about how it actually works and whether we haven't controlled for the wrong thing, or whether we made some, perhaps accidentally, some selection errors somewhere and not coming up with the right answer in one way or another. That's not a bad thing, that's progress, right? If we have these discussions about all these things that can go wrong in causal inference, that's progress. But we shouldn't just say, okay, there's no consensus yet, and so we shouldn't do anything. We should just be clear and acknowledge, okay, there's some uncertainty here. We don't know exactly how it works. It might work like that, it might work like that. This might seem the best course of action given what we know, right? But we need to be clear about what we can expect in terms of outcomes, what type of causal thinking is behind it, so that we can at least have a clear discussion about how we think stuff works in the end. And there I'd like to conclude. So thanks for your time and for your attention.